So we know what is a quadratic formula. It's an equation where the power of x, the variable, is 2. How about fourth degree equations? That is, the power of x is 4. In general, it's a very hard problem to solve. It was first fully solved by an Italian mathematician called Ferrari. Not the car, the mathematician. Today, we will learn a very smart technique to solve certain fourth degree equations. And we will do that using a problem from American Mathematics Competition 8. It's a very beautiful math Olympiad. Check the link in the description to get more resources on that. This video is sponsored by Cheenta.com. Since 2010, Cheenta has trained thousands of students from all around the world in mathematical Olympiads, physics Olympiads, computer science and informatics Olympiads, ISI CMI entrances, and research projects for school and college students. Suppose we want to solve this particular equation, x to the power 4 minus 10x square plus 9 equal to 0. This is from a problem from AMC 8, as I told you. It's a little bit modified. It's not exactly that problem. I modified it to make it a little bit more fun. Anyway, so the general strategy should be to complete the square. To complete the square. So what does that mean? It means you would want to use the formula of a plus b whole square, which is a square plus 2ab plus b square, or you would want to use a minus b whole square, which is a square minus 2ab plus b square. You use one of these two formulas. And try to convert a part of this equation into a perfect square. This is in fact a strategy for solving any sorts of polynomial problems. So let's see how we can do that. We have x to the power 4, which I can write as x square whole square. Then we have minus 10x square. So that I can write as negative 2 times 5 times x square. Plus, so this is a square minus 2ab, then I would need b squared to complete the square, right? So I would forcefully introduce 5 square here because that would be my b square. But I would also subtract 5 square because it was not there originally. I cannot change the expression, so I will add and subtract the same thing. And then I will add a 9. So let's add a 9 because that was there. This is equal to 0. So what do we have now? Well, we have x square minus 5 whole square minus 25 plus 9 equal to 0, which means x square minus 5 whole square equals to 16. This was in fact the original equation from the AMC 8 problem. So you would like to solve this. Now this one is quite easy to solve. We can take square root on both sides. Now you have to be very careful here, because when you take square root of an unknown quantity, so you don't know what this is, right? You don't know the value of x. If you take the square root of an unknown quantity, you get absolute value of that quantity. So square root of x square is equal to absolute value of x. It could be positive, it could be negative. X itself could be positive or negative, right? So this is x square minus 5 is equals to 4. Square root of 16 is 4. So We don't know what this quantity inside is, but its absolute value is 4. The absolute value of this quantity is 4. Now, absolute value of two numbers is 4. Of course, one of them is 4 itself. The other one is -4. So this quantity inside have to be either 4 or -4 so that its absolute value is equal to 4. So keep that in mind, this particular step. This is a critical step that many students get wrong. So what we have is x square minus 5 is equals to 4, or x square minus 5 equals to -4, which means x square itself is either 9 or it's 1. So we are almost done with this solution. Can you put the final value of x in the comment section? And also tell me any other beautiful strategy that you know to solve 4th degree polynomials. Cheenta programs are designed for students who are passionate about mathematics, and they are personalized with one-on-one training, individual evaluation, and remedial sessions. The reason Cheenta students are successful over the last 10 years because they are taught by mathematicians and real Olympiads from leading universities in India, United States, and Europe. Some of our students come back to teach at Cheenta from Oxford, Cambridge, Harvard, MIT, UCLA, ISI, CMI, IITs, TIFR, and IISc. For more information, visit cheenta.com.